Hello everyone and welcome back to Today we're unlocking the mysteries of X-rays. Imagine being able to peek inside the human body, observing the intricate workings of our bones and organs without making a single cut. This is the power of X-rays, a marvel of modern medicine. These invisible rays, part of the electromagnetic spectrum, are much like the light we see and the radio waves we use to transmit information. Yet, they possess a unique ability to penetrate matter, creating a window into the human body. This capability has not only revolutionized the way we diagnose and treat diseases, but also deepened our understanding of the human anatomy in ways previously unimaginable. As we unravel the secrets of X-rays, we will explore their origins, their interactions with the human body, and their profound impact on medicine. So, ready to dive into the fascinating journey of X-rays? Let's get started. Scene script. First things first, how do these mysterious X-rays come into existence? Well, it all starts with a device called an X-ray tube. Picture it as a sort of high-tech light bulb. This tube is filled with a vacuum, and on either end, it has two electrodes, a cathode and an anode. The cathode, or the negative electrode, is a coiled wire filament. When electricity is passed through it, the cathode heats up, releasing electrons through a process known as thermionic emission. It's kind of like a microscopic fireworks display, with electrons being the sparks that fly off the heated filament. Meanwhile, on the other end of the tube, we have the anode or positive electrode. This is typically made of a heavy metal, like tungsten, which has a high melting point. When the cathode releases those electrons, they are attracted to the anode due to the difference in charge. Now here's where things get really interesting. These electrons are racing towards the anode at nearly 2/3 the speed of light. When they collide with the anode, their high-speed journey comes to a sudden halt. This abrupt stop causes the electrons to release their kinetic energy in the form of X-rays. Imagine it like a car crash. The electrons are the car, and the anode is a brick wall. When the car hits the wall, all its energy has to go somewhere, right? In this case, that energy is converted into X-rays. But not all collisions produce X-rays. In fact, only about 1% of the collisions result in X-rays. The rest is released as heat. That's why the anode is made of heavy metal like tungsten, which can withstand high temperatures. So in essence, what we have is a super fast, micro-scale game of bumper cars happening inside the X-ray tube, with each collision potentially producing a burst of invisible X-rays. So that's how X-rays are born. But how do they interact with our bodies? Let's find out. Now we have our X-rays, but what happens when they meet the human body? Well, let's think of X-rays as explorers, venturing into the unknown territories of our bodies. These enterprising adventurers don't just pass through, they interact with the tissues they encounter along their journey. Their interaction with different tissues, be it bone, muscle, or fat, varies. You see, X-rays are a bit like social butterflies. They have three main ways of interacting: absorption, transmission, and scattering. Absorption is where the X-rays are taken up by the tissue. This often happens with denser tissues like bones, which absorb more X-rays and appear white on the final image. Transmission is the complete opposite. This is where the X-rays pass through the body without any interaction. It's like they're on a sightseeing tour, just passing through and enjoying the view. Lastly, we have scattering. This is where the X-rays hit a tissue and then scatter in different directions. It's a bit like a pinball machine, with the X-rays bouncing around. These interactions are crucial because they determine what we see on the final X-ray image. The varying degrees of absorption, transmission, and scattering give us the contrast we need to distinguish between different types of tissues and structures inside the body. Now that we know how X-rays interact with our bodies, let's see how we capture these interactions to get those iconic images. Scene script. X-rays have interacted with the body, but how do we capture this interaction? Imagine you're in a dark room and you flick on a flashlight. The light travels from the flashlight, bounces off objects in the room, and returns to your eyes. This is essentially what happens in radiography, but instead of visible light, we use X-rays. And instead of your eyes, we use a detector. When X-rays are emitted from a machine, they travel towards the body. Different tissues absorb different amounts of X-rays, with denser tissues like bone absorbing more and appearing white on the X-ray image, while less dense tissues absorb less and appear darker. Once the X-rays have passed through the body, they hit a detector. This detector can be a classic film, similar to those used in old cameras, or a digital detector. Both types of detectors convert the X-rays into a visible image. The areas where fewer X-rays hit the detector appear darker, creating a shadow of the body part being examined. But it's not just about capturing a static image. With the advent of digital technology, we can now create real-time moving images using a technique called fluoroscopy. This gives doctors the ability to view moving body parts like the heart or lungs, making it easier to diagnose and treat a range of conditions. But as we capture these images, we must not forget about safety. While X-rays are incredibly useful, it's important to remember that safety comes first. X-rays, like all forms of radiation, can have harmful effects if not used judiciously. This is why it's imperative to minimize exposure. Now, you might be wondering, how is this possible? Well, there are several protective measures in place. For patients, the exposure time is kept as short as possible, and only the necessary area is exposed to the X-rays. Additionally, lead aprons or shields are often used to cover other parts of the body. As for healthcare professionals who work with X-rays, they also take precautions. They wear lead-lined aprons and gloves, use dosimeters to monitor their radiation exposure, and often stand behind a protective screen or leave the room entirely when an X-ray is taken. Remember, the goal is to balance the immense benefits of X-rays with the potential risks. With safety in mind, let's explore some of the amazing applications of X-rays in medicine. From diagnosing fractures to detecting tumors, X-rays have truly revolutionized medicine. Imagine being able to see inside the human body without making a single cut. That's the power of X-rays. They give us a window into the inner workings of our body, enabling doctors to diagnose diseases and injuries with remarkable accuracy. Take a moment to consider the sheer variety of applications. Whether it's identifying a broken bone, locating a foreign object, or even examining our teeth, X-rays are a vital tool in modern healthcare, but their impact goes beyond the everyday. X-rays have played a pivotal role in major medical breakthroughs. In the early 20th century, for instance, X-rays contributed to our understanding of DNA by revealing its double helix structure. This discovery revolutionized biology and medicine, laying the groundwork for countless advancements from genetic engineering to personalized medicine. And there you have it, a brief journey into the world of X-rays. Until next time, stay curious.